Alright, so today we're going to be doing linear inequalities and linear programming. So we're going to be building on what we have done so far. So for example, so far we may have had an example where we drew one inequality and we found out which side was being shaded. Then we drew another inequality and we figured out what side was shaded. And then from both of these systems of linear inequalities, we're able to find a solution set, which we can see as these doubly shaded regions. But now, today, we're going to be interested in these corner points right here. And we know that we're going to be plugging these corner points into either a profit or a cost function. And then that way we can see which points in our solution set will maximize our profit and which points in our solution set will minimize our cost function. And then given that we know this is the solution set, given our linear constraints, there's a nice property that we know that the corner points are going to be, one of these corner points is going to be a point that maximizes our profits or minimizes our costs. We're not going to be too concerned about one of these interior points. That point's not going to maximize our profits or minimize our costs. Nor are we going to be interested in a point that is in the middle of one of these straight line regions. We know that this point right here, or any other point that falls on the middle of one of these lines, these points will not be points that maximize our profits or minimize our costs. We're only going to be interested in these four corner solutions. Alright, so let's do an example. So let's suppose we want to maximize P equals to 50x plus 80y subject to 3x plus 4y has to be less than or equal to 84, and x plus 2y has to be less than or equal to 32. Alright, so this is kind of right here is what we have figured out so far in class. So let's deal with that part first. Alright, so we're going to want to graph y, x. And we're only going to be interested in the first quadrant. Alright, so let's deal with this first linear inequality first. So when x equals 0, we know that 4y has to be less than or equal to 84, or y has to be less than or equal to 21. So we got the point 21, and we know y has to be less than or equal to 21. And then when y equals 0, we know 3x has to be less than or equal to 84, or x is going to have to be less than or equal to 28. 28. And we know x has to be less than or equal to 28. So we can draw a straight line in between these 2 points, and we can shade in the region that's respected inequality. Okay, now let's deal with this second inequality where we have x plus 2y has to be less than or equal to 32. So when x equals 0, we know that 2y has to be less than or equal to 32, or y has to be less than or equal to 16. So we got 0.16, and we know y has to be less than or equal to 16. When y equals 0, we'll have the equation x has to be less than or equal to 32. That's nice when it's already kind of done for us a little bit. And we know that x has to be less than or equal to 32. So we can draw a line between these 2 points. We can shade in the respected inequality for that linear inequality, and then we can see the doubly shaded region that is marked off by these 4 points. Alright, so we're going to have to label all 4 of those points. We know that this point, well, that's just the origin. This point right here is the point 28, 0. This is the point 0, 16. What about that point? Well, now we have to do some arithmetic, because that point is going to be where the equation 3x plus 4y equals 24 intersects the line x plus 2y equals 32. And now we got 2 equations and 2 unknowns, and we got to solve for both of those unknowns. So from this equation, we know that x is equal to 32 minus 2y. We can then plug that x for this x here, and we're going to get 3 times 32 minus 2y plus 4y equals to 84. We're going to distribute that 3 in, so we're going to get 96 minus 6y plus 4y equals to 84. If we combine our like terms of our y's, we're going to get 96 minus 2y equals to 84. We subtract 84 to both, or 96 to both sides. If we subtract 96 to both sides, we're going to get negative 2y is equal to negative 12, or y equals to 6. If y equals to 6, we can plug that back into this equation right here, and we're going to get x equals to 32 minus 2 times 6, then in brackets, or x equals to 32 minus 12, or x equals to 20. Alright, we know x equals to 20, y equals to 6. That is the intersection of those 2 lines, and that is that corner solution for this solution set. Alright, so we have mapped out our entire solution set, and we know the points to all the corner solutions. And then it's just a nice little tidbit fact that we know that one of these corner solutions is going to maximize this equation up here. So what we're going to have to do is plug in all 4 of those points into this equation, and then find out which one maximizes that original equation. So let's deal with I would say the easy one first. If we know that p equals to, what is it, 50x plus 80y, 50x plus 80y, we're going to have p equals to 50 times 0 plus 80 times 0, and we're going to get p equals to 0. So that's one of our possible answers. So we can plug in another point, maybe the point 0.16 into the original profit function. So 0.16, the profit function is still going to be 50x plus 80y, but in this case it's going to be 50 times 0 plus 80 times 16, and 80 times 16 equals to 1,280. So that is another possible answer for maximizing the profit function. Alright, let's deal with this next point that could possibly maximize the profit function. That's the point 28, 0. So dealing with the point 28, 0, we're going to have the profit function still going to be 50. Well, I'm just going to jump up ahead a little bit and just say put 28 right here plus 80 times 0. When 50 times 28 is just going to be 1,400. Alright, so let's deal with this last one, 20, 6 as a potential point that can maximize our profit function. 20, 6. We're going to have the profit function be 50 times 20 plus 80 times 6. Alright, so 50 times 20, 1,000, plus 80 times 6, that's 480. So we're going to get a profit of 1,480. So we have 4 potential points that maximize the profits. We had ended up with profits of 100. Well, that's not going to maximize profits. We have a potential profits of 1,280. That's not going to maximize profit. We also have a potential profit of 1,400. That doesn't maximize profit. And lo and behold, this is the last one that we figured out. The points 26 is going to be what maximizes the profit. So when x equals 20 and y equals 6, we maxed profits. Yay! So that's how we come up with the solution to that type of question. Alright, so that's how we did it. So what we originally did is that we graphed the inequalities that we were dealing with, found out the corner solutions to the solution set, plugged those corners to the solution set back into the profit function, and then found out which one maximized the profit. Let's do another example. Specifically, let's deal with a word problem. So we have the word problem. A furniture manufacturing company manufactures dinner room tables and chairs. It takes 8 hours to assemble a table, 2 hours to assemble a chair. It takes 4 hours to finish a table and 1 hour to finish a chair. The firm has 400 hours available for assembly and 120 hours available for finishing. The firm earns $90 profits per table and $25 per profits per chair. How many tables and chairs should the firm produce to maximize profit? Alright, let's first solve what we'll figure out what the profit function will be. So the profit function is simply going to be, let's go back to black. The profit function is going to be 90 times T plus 25 times C. So T represents the total number of tables that we make. C represents the total number of chairs that we make. So if we earn a profit of $90 per table and $25 per chair, the total profit is simply going to be $90 times the number of tables that we produce plus $25 times the number of chairs that we produce. Alright, but we're going to have to subject this to our ability to assemble and finish chairs. So we need to come up with one equation that deals with the assembly, and we're going to have to come up with another equation that deals with the finishing. So let's go back to the second sentence that we have here. It takes 8 hours to assemble a table and 2 hours to assemble a chair. So 8 times T plus 2 times C. Well, that's the total number of hours that we devote to assembling. And look back here, we have 400 hours available for assembly. So it has to equal to less than or equal to 400. Alright, let's go back to this third sentence here. It takes 2 hours to finish a table and 1 hour to finish a chair. So 2 times T plus 1 times C. It's the total number of hours we spend finishing. And we can see that we only have 120 hours available for finishing. So that has to be less than or equal to 120. So we have set up our problem. We know that this is the profit function that we need to max, pi equals 90t plus 25c, and it's subject to these linear inequalities. Alright, so we're going to want to graph this. Let's deal with this inequality first. So let's have t be our so-called y-axis and c be our so-called x-axis. So when c equals 0, we know that 8t has to be less than or equal to 400, or t has to be less than or equal to 50. So we're going to have 50. T has to be less than or equal to 50. And then likewise, when t equals to 0, we're going to have 2c has to be less than or equal to 400, or c has to be less than or equal to 200. Mark off 200, and we know that c has to be less than or equal to 200. Draw a straight line between those 2 points. Fill in the respected inequality zone. Alright, let's deal with this second equation now. Dealing with this finishing equation. So once again, when c equals 0, 2t has to be less than or equal to 120, or t has to be less than or equal to 60. We plot the point 60, and we know t has to be less than or equal to 60. When t equals 0, we're going to add the equation c is less than or equal to 120. Mark off 120, and we know that c has to be less than or equal to 120. And we're going to graph the straight line between these 2 points. We are going to fill in the respective shaded region with this one linear inequality, and then we can see the solution set where both of these inequalities overlap. It's going to be a point here, going to be the solution set marked off by these 4 points. We can shade this area in a little bit. Alright, so let's mark off these points. We know that the origin, we know that we're going to have the point 120, 0. We're going to have the point 0, 50. And then what about that point? Well, that's going to be the point where the lines from those inequalities intersect. So we're going to have 8t plus 2c equals to 400, and we have 2t plus c equals to 120. We got to figure out where those 2 lines intersect, and that will give us the c and t value for that point there. Alright, so we know that c is going to equal to 120 minus 2t, and we're going to plug that 120 minus 2t for this c here. So we're going to have 8t plus 2 times 120 minus 2t equals 400, or otherwise 8t plus 2 times 120, 240. 2 times negative 2t minus 4t equals 400. Combine our t's together, 8t minus 4t, 4t plus 220 equals 400, minus 240 to both sides, so 4t equals to 160, and t equals to 40. And now, if we know t equals to 40, we can plug in that 40 into that c equation right there, or c equals to 120 minus 2 times 40. 2 times 40 is 80. C equals 120 minus 80. C also equals 40. Alright, so we know the point right here is going to be the point 40, 40. So we have mapped off all our corner points to the solution set from the linear inequalities. And we're going to have to plug all 4 of those points back into this profit function that we originally came up with. So remember, P profit equals to 9dt plus 25c. And we're going to plug in all 4 points. So let's start off with what I would say the easier one. So for the point 0, 0, we're going to have profit equals to 90 times 0 plus 25 times 0, or profit equals to 0.00. Let's work with this point right here, the point 120, 0. Remember that 120 is representing the c-axis. So profit will equal to 90 times 0 plus 25 times 120. And we'll get, what's 25 times 120. Profit equals to 3,000. All right, let's deal with the point right here, 0, 50. 0, 50. The 0 represents the C and 50 represents the T. So we're going to get profit equals to 90 times 50 plus 25 times 0. 90 times 50, we're going to get profit equals to 4,500. And then we're going to plug in this last point as a potential solution. 40, 40. And we're going to get pi equals to 90 times 40 plus 25 times 40. And we're going to get 90 times 40 is 3,600. 25 plus, or 25 times 40 is an even 1,000. 3,600 plus 1,000 equals $4,600. So out of our 4 potential profits, profits of 0, profits of 3,000, profits of 4,500, or profits of 4,600, which is the greatest profit? Well, $4,600. And what combination of chairs and tables that we can sell that gives us the maximum profit? Well, 40 tables and 40 chairs will max profits. Yay! And that's how we did it. All right. Well, that is it for today's lesson.